right, today is test review day for geometry. The test will be assigned on Google Doc, and it will be due Tuesday at 11:59 p.m. That's tomorrow at 11:59 p.m. Okay, so let's start with problem number 1. There'll be 6 questions today, and 6 questions on the test. Okay, so the sine of angle theta is 3/4, and it's given that the angle is in quadrant 2. Okay, so first things first, let me get my pencil. Okay, so the sine is 3/4 and we're in quadrant 2. Well, the quadrant 2 part tells me that it's going to be between 90 and 180. So what I like to do is draw a picture so I get a good sense of what's going on. So I'm going to rotate, make a little arc, and I'm just going to be somewhere in this diagram. My point ends up in quadrant 2. So I want to figure out what this gray arc is. But in order to do that, I got to use trigonometry in quadrant 2, where the terminal point meets the x-axis. So whatever line forms from the origin of the xy plane to the x-axis is going to be my reference angle. So that's going to be my reference angle theta. So now, if I were to just drop that down, I get a right triangle. So now I'm trying to figure out how to solve for this angle theta using the sine of theta is equal to 3/4. So I've drawn this triangle. My angle theta is here. And I'm going to use the sine of theta. Well, I'm going to use my SOH part of the acronym, SOH. Remember that SOH is sine, the opposite over the hypotenuse. Well, if the numerator is 3, that means that the opposite side of theta has to be 3. And the hypotenuse is the denominator, so that's 4. So if I look at my angle theta, my opposite side is 3 units, and my hypotenuse is 4. And now that gives me enough information to solve for angle theta. So now I've got the sine of theta is equal to 3/4. Well, how do I undo that sine function to get angle theta isolated? I'm going to apply sine inverse on both sides of the equation. So if I apply sine inverse on the left and sine inverse on the right, that gets the angle theta isolated. The inverse function cancels out with the original function, and that gets us to the identity, the angle theta. So now I'll pull out my calculator, make sure you're in degrees. Okay, mode, clear. Mode, degrees, cool. So I'm going to do second and sine, that activates the sine inverse button. The sine inverse of 3/4 is 48.590. So 48.590 is going to be my angle. But remember, that is my reference angle. I'm trying to figure out what this gray angle is. So remember, that's just my reference angle. But in order to figure out what the gray angle is, the arc itself, I need to use my quadrant 2 formula. Well, let's just think common sense about this. That if the entire arc plus the reference angle equals 180 degrees, I'm going to take away this reference angle and solve for the gray arc. So Q2 angle is equal to 180 degrees minus that reference angle, 48.590 degrees. So let's subtract that from 180. Sorry about that. I accidentally put in front. So that's going to get me 131.41. Now, if you want to check your work, you can always compare the sine of the angle that you figured out, sine of 131.41, And since 3/4 as a decimal is 0.75, I bet you that this angle is going to be, 131 degrees, 131.41 degrees. That sine ratio is going to be about 3/4. 0.749999. Yeah, there we go. Pretty much 0.75. The more decimal places you use, the more accurate your solution will be. Okay. Problem number 2. The cosine of angle theta is 3/8, and we're in quadrant 4. So what that tells me in quadrant 4 is that it's going to be between 270 and 360. So I like to draw a picture. So let me get my pencil. So I'm going to make an arc. I'm going to go past the 90-degree angle, past the 180-degree angle, past the 270-degree angle, and make a terminal point somewhere in quadrant 4. So now I want to take the terminal point and sandwich it with my x-axis. So therefore, that creates a 90-degree angle where my angle theta is here. Okay, so now that I've drawn this triangle, I've got angle theta right there, and I'm using the cosine ratio. So what that tells me is it goes to that SOHCAHTOA mnemonic that we just figured out. Well, CAH. Okay, so that tells me that it is the adjacent over the hypotenuse ratio. So the top part is the adjacent side, which is 3. The denominator is the hypotenuse, which is 8. So therefore, if we've got an angle theta, 3 is the adjacent side, and 8 is the hypotenuse. So this is what our triangle looks like right now, just in quadrant 4. Okay, so now that we've got the cosine of theta is equal to 3/8, how do I undo cosine to get theta isolated? I'm going to undo the trig ratio with the inverse trig function. Apply cosine inverse to the left side and the right side to solve for angle theta. So the cosine inverse cancels out with the trig function cosine, leaving us with the identity element theta. Now we apply the cosine inverse of 3/8 in the calculator. And that's going to get me 67.9756. Well, we're rounding to the nearest 3 decimal places. So 975 rounds up to 976. So 67.976 degrees. But remember, that's just the reference angle. We want to solve for the big arc. Well, if this angle theta is 67.976 degrees and I want to solve for the big arc, how do I complete that big arc? Well, together the big arc and the reference angle must equal 360. So let's just take that reference angle arc and then we'll get that Q4 angle. So the Q4 angle, quadrant 4, is basically 360 degrees minus that reference angle. And now we're going to confirm. So 360 minus 67.976 is going to be 292.024 degrees. And if you want to check your work, see if your angle, the cosine of your angle, cosine of 292.024 should match up with 3/8. And remember, 3/8 is 0.375. They match up almost identically. 0.375, 0.37499, yeah, exactly. So you'll get, the more accurate your solution will get when you have more decimal places. Let's just go with 3. Okay, but that's how you check your work. Okay, problem number 3 now. The tangent of angle theta is equal to 2/3, but we're in quadrant 3. So if we're in quadrant 3, where is the angle going to be? Right there, bottom left of the XY. So if I were to start out here, I'm just going to draw an angle that goes past 180 but below 270. So let's just draw an arc. That's good enough. It doesn't have to be exact, but I'm just going to draw an arc right there. Now remember, we're drawing where the terminal point matches up with the x-axis, so that angle is going to be right here if it's in quadrant 3. And then I'm just going to drop it from there, and that's my right angle. So now, tangent, TOA, that's what I go with, TOA. So tangent is the ratio of an angle's opposite side to its adjacent side. The top part is the opposite side, so the opposite is 2, and the adjacent side of that angle will be 3. So therefore, if I put angle theta in the corner, that would mean that the opposite side of angle theta should be 2, and the adjacent side of angle theta should be 3. So now it turns into a solve the right triangle in quadrant 3. So let's just pretend it's just a regular right triangle, but we're in quadrant 3. So the tangent of theta is equal to 2/3, and I'm going to undo that tangent layer by applying tangent inverse to both sides of the equation. So now that tangent inverse cancels out with tangent, I'm left with angle theta. So now I pull out my calculator. The tangent inverse of 2/3 is 33.6900, so 33.690 degrees. And remember, that's just my reference angle. I want to solve for the big arc. So if we're in quadrant 3, I want to solve for the big arc. Okay, well, how do I get that big arc? Well, from 0 to 180, that creates this half circle. And plus the reference angle makes the Q3 angle. So if 180 plus the reference angle is the Q3 angle, well, if I just want the Q3 angle, I'm going to add those two together. So Q3 angle is equal to 180 degrees plus the reference angle, 33.690. Well, remember, this is an approximation, so I'm going to put squiggles. 30 plus 180 is 210, so I bet you this is going to be 213.690 degrees. And the way I can check my work is applying the tangent of 213.690 in the calculator and compare that to 2/3. 0.66664, and 2/3 itself is 0.6 repeating. Pretty darn close. Okay, moving on to problem number 4. All right, now we're in dangerous territory. The tangent of theta is equal to -7/3. Don't be scared of the negative. Make it a triangle. Make it a right triangle that you're familiar with. Don't be scared of the negative. So let's take a look at this. Well, if we're in quadrant 4, okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4, we're in the bottom right of the triangle, bottom right of the XY. So in the XY plane, if we were in quadrant 4, let's make a angle. Let's just say it's right around there. Doesn't have to be exact. Well, if we're in quadrant 4, that means that the terminal point and the x-axis form an angle called a reference angle. So we're going to put an angle theta right there. Okay. So our goal is to solve for the reference angle to solve for the gray angle, the gray arc. So let's make a 90-degree angle right there. So considering that the tangent is opposite over adjacent, I'm going to just ignore the negative sign right there. But you know what? The solution itself is going to have a negative tangent. So remember that we're in the world of tangents, so that's opposite over adjacent. So let's just call the opposite 7 and the adjacent 3 for angle theta. So 7 is the opposite side, 3 is the adjacent side, and we'll use this to solve for the gray arc. So since the tangent of theta is 7/3, my goal is to undo that layer of tangent to solve for angle theta. So now I'm going to apply tangent inverse on both sides to solve for the unknown angle. So that knocks out. We've got angle theta. So now we've got the inverse tangent of 7/3, which is 66.801 degrees. Okay, but remember, that's only my reference angle. I want to solve for the entire arc. Well, remember it's in quadrant 4. So what information can I use if I know the reference angle and I want to solve for the gray arc? Well, consider that the arc plus the reference angle equals 360. Well, if I just take away the reference angle from 360, I should be able to solve for the gray arc. So therefore, the quadrant 4 angle is equal to 360 degrees minus the reference angle, 66.801 degrees. I'm going to put a little squiggles. So 360 minus 66.801 is approximately 293.199. So, in order to check your work to see if you got it correct, compare the trig ratio of the quadrant 4 angle with the negative 7/3. So let's go with negative 7/3, just to get an idea. I believe it's negative 2.333333. Yep, negative 2.3 repeating. And I'm going to compare that to the tangent of 293.199. Nearly identical. Even got the negative sign and everything, because if the sine is negative and the cosine is positive, that creates a negative tangent in the bottom right. Okay? 2 more questions, and then you will be assigned the test. Sine of theta is negative 1/3 in quadrant 3. Okay, well, I'm going to ignore the negative because that makes me a little bit anxious. But why is the sign negative? Because it's in quadrant 3. Quadrant 3 is in the bottom left, so I'm just going to make a little arc. Okay. Past 180, below 270. And considering that the terminal point needs to form an angle with the x-axis, I'm going to form my angle theta right there. And that forms my right angle with the x-axis. Okay, sine, so. Okay, so that creates an opposite over a hypotenuse. Let's just take away the negative sign for now and just make an angle theta with a 90-degree angle. And the opposite needs to be 1. The hypotenuse needs to be 3. So this is what your diagram looks like, where you solve for angle theta as a reference angle. Okay, so now that I've got the sine of theta is equal to 1/3, how do I undo that layer to solve for angle theta? I'm going to apply sine inverse on both sides of the equation. Because now the sine inverse and the sine cancel each other out, leaving me with angle theta. I'm going to pull out my calculator. Sine inverse of 1/3. 19.4712. That's just going to round down to 19.471. So 19.471 degrees is our reference angle. So because we have our reference angle, we've solved for this angle theta, we can solve for the gray arc. Well, let's look at the quadrant 3 angle. Well, the quadrant 3 angle is formed by combining 180 degrees with the reference angle. So Q3 angle is equal to 180 degrees plus the reference angle, 19.471 degrees. Well, if 180 plus 20 is 200, I think 180 plus 19 is 199.471 degrees. We just tacked on the decimal. So there you go. And if you want to check your work, let's compare the sine of 199.471 degrees and compare that with negative 1/3. Negative 1/3 is negative 0.333333333, negative 0.3 repeating. And a sine of 199.471 degrees is pretty much the same output. Even got the negative sign and everything because it's in quadrant 3. The y value is negative in the third quadrant. All right, one more and then we'll call it a day. The cosine of angle theta is negative 7/9 in quadrant 2. Okay, well, where is quadrant 2? Top left. So I'm just gonna make an arc where it ends up in quadrant 2, and because our terminal point needs to match up with the x-axis, that's going to be my angle theta. And that angle theta creates a right angle with the x-axis. So now, ignore the negative sign. That causes me anxiety. Just ignore it. Cosine. What is that? Adjacent over hypotenuse. The adjacent side of angle theta has to be 7. The hypotenuse of angle theta has to be 9. So now that I've got my angle theta in the diagram, adjacent is 7, hypotenuse is 9, solve for that reference angle. So now that I've got the cosine of theta is equal to 7/9, how do I get angle theta isolated? Well, the way to solve for an unknown angle is to use an inverse trig function. So I'm going to apply cosine inverse to both sides of the equation. Inverse functions cancel each other out to get to the identity, angle theta. And angle theta should be approximately, rounded to the nearest 3 decimal places, cosine inverse of 7/9. 38.942, the last digit is 4, so I'm just going to round down to 38.942 degrees. So now, that's just my reference angle. Let's solve for the arc. So now that I want to solve for the arc in quadrant 2, well, if I know what angle theta is, how do I figure out what the arc is? If they are supplementary, if the arc plus the angle makes 180 degrees, I'm going to subtract the reference angle and get that black arc. So the Q2 angle is equal to 180 degrees minus 38.942 degrees. So what is that approximately? (180 minus 38.942), 141.058. I'm going to box it, and I'm going to check my work for the final time by comparing the cosine of 141.058 and compare that to -7/9. Pretty identical. Well, good luck. The test will be assigned, and it'll be due tomorrow at 11:59 p.m. Thank you.